We are here today to talk about hype-driven development, but let us firstly introduce ourselves. Um, my name is Anna Konopka,
And I'm Grabarz.
and we are front-end developers at Montreal. Montreal is a software development agency, and we on a daily basis develop many different applications. And because of that, we have to use different stacks and different technologies. And I think that these conditions somehow made us learn how to deal with hype-driven development, because if you have to make such technical decisions on daily basis, because we are starting a lot of projects each day, you have to know what you're doing actually. But before we start and get down to really details, I would like to tell a few words about what is exactly this hype phenomenon. So it usually goes this way. A startup or a development agency is having some problem, and it's a problem that they cannot find any solution for on the market, or they think so, but there is none, and they decide to develop their own. Later, they open source the code, and being so proud of what they achieved, they are giving a lot of talks on conferences, and influencers start to tweet about that, and this is how the hype train starts its journey.
Have you ever wondered how many decisions are you making every single day? And if you trust your internet sources, it's probably around 35,000 of them. And many of those decisions you're actually making when writing your code at your work or at home. And they influence the code. Some of them may be as small, or for some actually it's a big decision, like naming a variable, but some of them are much higher caliber, like things that you cannot change easily in the future. Right. So have you thought about what's around you? How is your environment influencing the way you make those decisions? The conferences you attend, or the conferences, the Twitter feed you see every day, all of those things influence it.
Okay, but we are here to give you the tools that that you can use to avoid being hit by hype train, and to give you some intuitions about what to do. And okay, so what I should actually do when I see a new shiny framework. So the first thing that we usually see is README. And we usually skip the installation process as it's always the same, but we strive for details. And a few scroll events later, there they are. So seeing the code samples and docs, we know how to use the code that is inside this lib. So it tells us about the objects that we can manipulate, the public methods that we can use. So they describe the library API. And sometimes this API is a thing that really enchants us. So we strive to use that because it can give us better developer experience. Or just we like the way how it will work in our application, and we will use that. But it turns out that developers actually like different things. So we are different people and we have different preferences. And one example of that different tastes that caused a lot of trouble is JSX versus templates. So in this exact example, it all started with the introduction of JSX, and it began the holy war between Angular, JS, and React. And In this exact example, JSX and templates are covering different mechanisms for updating DOM structure. So in Angular 1.x, templates were actually the front part of a mechanism based on bindings and digest cycle. You probably know what I'm talking about. And in React, JSX is the front part of a mechanism based on virtual DOM diffing. But then Vue 2.0 appeared, and it turned out that actually JSX or templates might be just a different API to the same mechanism of updating DOM. So in Vue, both of them are compiled to just a set of plain JS function executions. So it's actually a matter of our choice which one we prefer and would like to use, because it's only the API level. And we can switch between them without risking of any degradation in performance or, for example, changing the way the framework behaves. Oh, okay. So what should we actually remember from this topic of library APIs? So one thing is that we should differentiate the library API part from the internals that are making real stuff. So sometimes it's better to actually deal with not so pretty API to be able to gain something in performance and just focus on the things that matter most for us. Because developer experience is nice, but it's not always the most important thing. The second thing to remember is to know that we are not the only one in the team and not only our decision matters. And when it comes to the discussion about the framework internals, so for example, between using virtual DOM or bindings, then it's a substantive discussion. But when we discuss about library API, it's only a matter of what one likes and prefer using. So having that in mind, we have to think that our teams are consisting of a lot of people, and we should choose something that would suit most of them.
Okay, so you see a new library with great API, and now you have to make a decision. And as you may know, it's the decision process that's making a good developer. So it has a lot of stars on GitHub. It's tempting to just go ahead and try things. But maybe it's the toy project you are going to try it in isn't the best place that will tell you about the real production issues. So we need a better way to deal with this problem. And we already have a process for that. That's the code review. We use it day to day on our own teams. So you could also read the code of the library you plan to use and check if it's not completely broken, is it properly tested, and maybe if you will be able to debug it later if necessary, because bad things will happen soon. Right, and in case of those, this process works very well on small-scale libraries, the specialized ones, but on the bigger frameworks, it's very hard to decide just by looking at the code. It's much harder. So here we have other ways to tell it, and that's the community and ecosystem of this library framework. Because it's always good to have somebody to ask for help in case something doesn't work for you. And in later, when you already learn it, it's good to learn more just by teaching others. So, and there will be a lot to ask about, because those ecosystems consist of many very specialized tools specific to the library you're planning to use. Well, there are a lot of CLIs, and having a CLI to generate the Bootstrap project for you, and with working server, hot reloading, that's definitely great developer experience, as long as it works for you. Because if you never really had any opportunity to learn how Webpack works, and it's mostly just a frontend to the Webpack, then when something breaks, it's very hard to debug. So now you have to think about how cutting edge the project aims to be, because fresh ideas tend to explode much more frequently than old but tested ideas. Cutting edge, like in React Native, for example, isn't always beneficial for you. It definitely gives you a lot of fun, but and solves real problems. But on the other hand, you have to be prepared to actively join the community, fix the bugs with them, and contribute to the whole process. On the other end of the spectrum, there are the stable things. But if you base everything on those stable things, it may be the case that you will very soon start to feel your project is boring for you. So you have to find your own balance between cutting edge and fun versus stable but boring. Okay. And okay, sorry. So have you heard about jQuery? Because the thing is, stuff that is now considered boring was actually fun back in the days, like just 10 years ago, and people were rushing to use it. So jQuery 10 years ago was just a new kid on the block. It totally destroyed modules and prototype, for example. But why it was actually so popular that people were confusing the JavaScript language with the jQuery. But why did it happen? Well, it definitely had to help with something, right? So, do you remember about Internet Explorer 6? Right. I hope you don't, but I see you probably do. It was not that bad, really. It was pretty good browser, except it didn't really work like any other. And all of them were very special snowflakes. And that's exactly what jQuery was good at. It was solving the browser compatibility issue. And now you were able to write a single piece of code that worked pretty much everywhere most of the time. You could also use the features like CSS inside your JavaScript. You are familiar with that already. Animate things on the screen, do a pretty easy Ajax call. That was a big deal back in the days. So believe it or not, even if you don't include JavaScript, even if you don't include jQuery to your library, right? Even if you don't include JavaScript to your code, you're most probably still using it in some way, because it was a solution to real problems, and those solutions were brilliant enough to inspire new standards. And those standards are known today as Fetch API, Query Selector, or CSS transitions. It was brilliant enough that those ideas live with us today. And you simply don't need JavaScript code behind it anymore. Okay, so sorry, forgot about it. Okay, so second point is the so you just go to your Twitter feed right now, and now you can see new technologies, because you don't have to worry about jQuery anymore. now you see a lot of new technologies like Webpack, Prepack lately, or Rollup, for example, and you look at them, and hey, they definitely solve a big problem. They enable you to optimize the bundle size of your application so much better than your current stack. But try to recall last time when you are actually thinking about this specific problem. Maybe it's simply not your problem. Because, well, we just like to look at things and find our way to use it before we actually think if we should. But on the other hand, your application may have a requirement that it should run very fast on mobile devices over slow 3G network, for example. But even then, you should think first, is it really the thing that will solve my problem? Is it the best thing I can do? Maybe you're just importing way too many stuff into your application, and you could optimize it by hand slightly and win much more. And this is very important because importing new library adds the overhead, not only for you. You're not the one who will maintain it eventually. It's your whole team. And by doing that, you force them to learn it. And also, every single library was created to solve a very particular problem, but often leaves you with two more. So you have to be sure that you are doing a trade that's profitable for you. Okay, so if jQuery was all right, why are we still trying to even invent new stuff and creating new frameworks every day, essentially?
Well, if you fix the most pressing problem, the next one appears. So it turned out that our front-end applications are not only about browser compatibility, and it turns out that front-end frameworks are really solving a few typical problems that we have to deal with on front-end side. And these are, we can say about them as pieces of the puzzle. And one of those pieces are UI elements. So we have to have a way, these are the building blocks of our views. They are composable and reusable, and they have this knowledge about how to render themselves on the screen and display something. The second thing is that we have to always keep in sync our data with our view. This is like one of the problems that we have to deal on front-end side. And there are many solutions here to choose from. For example, we can use the ones that I mentioned, such as virtual DOM and bindings, but we can also decide to use manipulate DOM manually. We also have to have some part of code that will take care of user actions and respond to user clicks or inputs. The next thing is that we often have some data from external API or any other external service that we use. And here, it's really dependent on the way we communicate via network, because there are different solutions for example, if we decide on REST or WebSockets or GraphQL. So, and in each of these categories, there are also plenty of solutions to choose from. We also have to somehow deal with the data that we store in our application and manage it in a nice way. And here are also many concepts like, should we store them should we store it globally or locally in our components? Should we do it in a centralized way or distributed way? We have many options to choose from. And of course, we cannot forget that in a single page application, we have to also take care of routing. And actually, it's a developer responsibility to fill all these pieces. Some frameworks are helping or have this attitude to provide you with a lot of them and not pushing the responsibility of choosing on a developer. And it's like in the newest Angular example or in Ember example. And some of them are leaving you more space to decide. It's more React style. But actually we cannot forget that it's our responsibility to ensure that all of these pieces will work together, especially if we choose them. We have to think about the interfaces in our applications between all of these pieces. We have to ensure that there will be no conflicts, and also, for example, think how it will work with our tools. We cannot forget about our build system and how it will go together, about our type system if we are using some, because there might be some conflicts here and we cannot forget about them. And actually the result of jamming one piece that doesn't match the others, I think it's not what we are looking for.
Right. So if there are so many shared problems, surely there are also some shared solutions between different libraries and frameworks how to approach those problems. And because why should you reinvent the wheel when you can just grab one that's already working, improve it a little, and just put it into your library? So as those patterns are inside the libraries, you can learn how some particular feature of library X works under the hood, and just by doing that, it will improve a lot the overall understanding of similar concepts in many different libraries. So how can we, where is the common ground? Where should we start? There is no magic. Everything that happens in your frameworks have to, in the end, be written in JavaScript. So anytime you spot a feature of the language itself that you don't know yet, you should be very curious about it. There is an example of a getter, which is usually not very known pattern in JavaScript, but actually it's pretty useful and it's used a lot in recent libraries. Okay, so how can we start then? Well, if it's JavaScript, we can just go ahead, code, and check. Let's say we are writing an Angular 1 template in our current app. So if you are working with your framework, you should, and you wonder how something works inside, there is nothing stopping you to check it. So in case of Angular template, here is a binding, simple binding, and you may be interested, how does it actually affect the DOM, or how it makes so that when the value updates, it's also changed automatically. You could try to search through the code of the library itself by the patterns like curly braces, something you're familiar with, but there is even a better way to do it. We can slightly modify the code, like change it to the change the binding to the function. Now we can put a breakpoint in this function, and later it's just a matter of opening your DevTools, refreshing the page. Is it visible? Kind of. Okay, you have to trust me that on the right side there is a call stack. So the code on the left, that's your code, you wrote it. So we are not interested in that today. You are mostly interested in the first entry in the call stack that actually is called from the library itself. In this case, that's the expression input watch. What does it mean? Well, it doesn't matter really. We can just click on it. And here we are inside of the Angular itself. And if you look closely, there is a function that's just a scope.watch. You already wrote that in your templates probably, which means that the bindings of the template itself are really watches underneath. What it gives you, what it learns, what can you learn from it? First, it's the fact that now you can apply any knowledge you have about watches immediately to every expressions in your templates. So there is one pattern. Second thing to notice here is, well, there is a digest cycle on this tag. Well, digest function. You may already heard of it. That's where the Angular checks every, that happens every time you touch something in your application. It checks your watches essentially. So there is a loop somewhere that goes through all of them. Okay, but why stop there? We are right now just inside a single framework. We can do even more than that. Let's say we can do exactly the same thing just inside the view, for example. The syntax is pretty similar, so it looks the same. Maybe there is a pattern. So again, we are writing a template with function binding, let's say, and a method that has a debugger call inside. So it also drops us into the DevTools. And now, if you inspect the call stack again, what can we see in it? Well, there is a watcher, so maybe it's something similar. You already have some intuitions about what can it mean. Also, there is no digest, so where does it actually check the things? How can it detect the changes? Well, the next step here, the next big thing here is the render function. So it's also the other way around. So there are many patterns inside, and I don't want to really explain how it works inside right now, because that would spoil you the fun. It's you who should really go inside, explore those patterns even more. And by doing that, every time now when you see a new library, because all of those things are essentially evolutions of the same idea that is with us from a lot of years. Every time you learn a new framework and you see an API, you can already make a pretty educated guess on how can it work inside of it. You don't have to learn everything from scratch every time. And it's also a very good exercise to go a few years back and, for example, look at the old libraries we used like 5 years ago. For example, the Backbone, or you'd be very surprised how similarly the Backbone Views API look to today's frameworks components. And maybe you heard about Knockout.js. It contains it contains the mechanism for tracking dependencies similar to Vue actually, and that was again a lot time ago. So right, so all of those ideas are essentially the same thing, and we can explore the pattern because our brains are really good at pattern matching after all.
Okay, so we provided you with some tools which we can use to avoid hype-driven development, but I would like to talk a little bit more about other activities that we can take to avoid that too. So we have, okay, so one of the activities that actually you might consider doing is deleting your Twitter account. I know that Twitter is actually currently depicts the heartbeat of front-end community, but the problem with Twitter is that the tweet is not long enough to tell you about all the pros and cons of using a framework or a library, about what problem it solves, or how do we work with that. But it's long enough to tell you, hey, framework X is great. And it's actually, you are left with this enthusiastic tweet, but you have not the faintest idea why you should use that. And actually, after reading all of those enthusiastic tweets and being to conferences, hearing talks like that one, you're like having this power to just sit and use all of that things. But it's not a bad thing to do actually, but one thing not to do is to put it straight into the project. Because sometimes it's better to wait, note it somewhere in your memory that something like this exists, necessarily with all of the pros and cons of using that and the solution that it solves. And then when you will come to such a problem, this solution will naturally appear in your mind. And the next thing is that I would like you all to be skeptical, because all of this fuss created is usually made by the ones that succeeded. So we usually hear only success stories. And the projects that failed are not so visible. And this kind of phenomenon is called survivorship bias. And it may lead to overly optimistic vision of a framework that is actually not really true. How often do we forget about that? So we have to remember about why we actually develop the code. So we write it for to achieve certain goals. Our code has to work, satisfy clients' needs, and sometimes also make money. And I wouldn't be myself if I haven't told you about the business perspective of writing code. And I know that switching a point of view for a developer is tough. I know, but it's also really valuable to look at the code that we are developing from this cost to value perspective. And actually, we have to think about the risks that we are taking, because with each technology, each new library we use, we have some risk connected. And these are different levels of risk connected with different technologies. But the most important question that we should ask ourselves is which level of this risk is bearable for the company or the projects that we are in. Because it will be different for a small startup or a big startup with lots of funds and lots of developers. It will be different for a big corporation and different for a development agency. And we have to think about what suits us the most. So many of the hype-driven developers are actually perfectionists, and they cannot sleep nor eat until their code will be perfect, or at least they will think so. And I'm actually really keen on keeping strong in terms of quality of the code, but rewriting a piece of app only to improve it by like 3%, it just doesn't pay off. And we have to think about the things that really matters from the business perspective. And how can we identify the things that matter from the business perspective? So we can ask ourselves a few questions connected with this business perspective. So will this rewrite ever pay off? Or how our decisions will influence the project we are in long term and in short term, but also a little bit of different questions. So for example, who will pay for the learning time, or how do we value the knowledge that we will get during it? or maybe how the improved developer experience will influence the speed of development. Maybe it's something that we aim for. So I know that these questions are hard to put into numbers, but actually it's not often needed. They are here to make us, to help us make an informed decision. And to sum up.
Okay, so if there is just one thing to take from this presentation, I would say that's that you shouldn't be too emotional about your code. Because in the end, it's just a medium to achieve a certain goal. And this goal can be anything, like learning or maybe writing an application for a client. So make that your first priority.
And I would like you all to remember about this idea of exploring the patterns, because it can give you a great intuition about what is really happening. And when you will see a next shiny thing on the horizon, you will know how to, because it will probably be similar to something. So we will have the intuition to know what is it exactly. And one last thought. JavaScript and front-end world has always been laughed at as really hype-driven. And people say even that 1 month in JavaScript world is like 40 years in other technologies. And yeah, our environment is developing really quickly, but at the same time, in my opinion, it's getting more and more mature. And it's actually our choice if we are going to be cutting edge and risk a lot, or prefer more stable solutions. Thank you.